All right, good morning, everybody.
Morning.
How is everyone today?
Pretty good.
Awesome.
Not bad.
Day 2, we've only got 4 days and 10 weeks left.
Is that all?
That's all. Yeah, it's going fast, right? All right. Any questions or issues or challenges with the first homework or the first ODP?
I definitely ran into the password issue you said yesterday. I tried to change it the first time and didn't actually read it, and it kicked me out and had to do it all over again. So
Okay. Did you get it squared away eventually, though?
Oh yeah, it's all done.
Cool. All right, so it looks like most people have done the ODP, and mostly 10s out of 10. So that's good, and I haven't looked at the homework yet. Cool, so we're good with that. All right, so I might have mentioned yesterday that you have 3 slip days to use for programming assignments. You actually have 4, so I was mistaken when I said 3. So you got 4 slip days to work with if you can't get something turned in by a deadline. So bonus there. All right, let's talk about Linux. So this course is largely about Linux. It's about working in a Linux environment and getting comfortable with doing the kinds of things we do in Linux. So let's talk about what Linux means, because there's usually some confusion about servers and CTEC and Linux and PuTTY and things like that. So let's square down some terminology. So Linux itself is an operating system. Windows is an operating system. OS X is an operating system. Android is an operating system. These are things that run when you turn on a machine. So if you boot up a Windows laptop, it runs this thing called Windows. It's basically a big gargantuan program that, notices when you move your mouse and moves an arrow around accordingly. And if you click on something and you're pointing at, an icon, it will open up a program in response to that and so on, right? So an operating system is a big program that basically helps you interact with things inside a computer, typically files and programs. And Linux is just a different operating system. It's actually a very old operating system, a few decades old, and I'll use the words Linux and Unix fairly interchangeably. They're actually very different things. But Unix is an operating system that goes back into the 70s. Created at Bell Labs. It was an internal product that eventually was commercialized and was used by a lot of schools, research institutions, things like that. And Linux is a free version of Unix. It's the same basic behavior as Unix, but it's written by people who created the software with the goal of letting anybody use it. And so it's an example of an open source system, meaning not only is the software free, but the source code for the software is freely available. And you can download the actual, usually it's C code that Linux was written in. You can download the actual C code that makes up Unix or Linux, and you can modify it, and you can give it to other people, and if you like, you can sell it. So it's a completely open operating system. But even without taking advantage of that, without going in and modifying the source code itself, we can do a lot of tailoring of a Linux environment to our own tastes. And so this is one of the themes that we're going to keep coming back to in this course, is this idea of customizing your computing environment. Um, Computer science for me is one of the best imaginable areas to be working in because it is so customizable, right? If I work at a desk, what kind of desk do I have? How tall is it? What does my keyboard look like? Do I have a mouse? Can I move my mouse around? What's the temperature in the office, right? There's all these things that are often out of our control. Inside the operating system, inside the Unix environment, I get to set things up however I want. If I don't like saying ls when I want to see my files, I don't have to. I can make my own command. I can make a command called Snuffy Smith, and when I type Snuffy Smith, it'll show me the files in my directory. If that's what I'm into, I can do that. When I open up a terminal window, for me, it's a black background with green text, because I find that comfortable. It's easy on my eyes. It doesn't distract me. If you like, something different, if you want a white background with dark text, if you want color coding, whatever you're into, right? There are all these different options. You can customize things. If I have really good eyesight, I can make my characters really, really tiny. If I'm feeling lazy, I can make my characters really big. And this is what people do when they work in Linux. You get to customize. You get to set things up to your liking. Have you used Arch? I think I dabbled it once a long time ago, but I use a pretty generic Linux. I'm running Xubuntu with, I believe I have KDE on top and a bit of GNOME and some other stuff like that. Most of what I do in Linux, I do from the command line by typing things and hitting enter, right? Linux, you can point and click, you can run graphical programs, you can run web browsers, all sorts of things like that. But you can do most of what you need to do for this course just from this command prompt, right? Where you basically type commands, and if you want to see your files, you can say ls, and if you want to know what directory you're in, you can say print working directory, and if you want to change directories, you can do cd, and so on and so forth. And we're going to concentrate pretty exclusively on the command line in this course. We'll play a little bit in one of the later assignments with creating graphical interfaces from a bash script. So we'll use some tools that will let us create things that we can interact with a mouse and point and click and so on and so forth. But by and large, we're going to stick to the command line. All right. So good reminder there. So yeah, you don't need to tell me you're here when you come in. You can wait until I do an attendance ping, except I forgot to do an attendance ping. So let's do attendance right now. So go ahead and send me a message with your name and a dash and uppercase here, just to let me know that you're here right now. And thank you to the person who came in and did that, because I would have forgotten otherwise. Good. All right, awesome. Thank you, everybody. All right, so we're going to talk a lot about customizing our Linux environment. Now, right now, I'm sitting on the Linux server, linux.engrcs.com. But let's talk about Linux kind of more generally, because there tends to be confusion around what is Linux, what is PuTTY, what is SSH, things like that. So let's pin down some terminology. So somewhere there's a machine called linuxengrcs.com. We can pretend that this is a PC sitting somewhere. I think it's in Pennsylvania, I'm not sure. But this is a PC sitting somewhere that is dedicated to this class. And oh, Zoom updates, always fun. So over here is Nick's laptop. And what I want to do is from my laptop, I want to do something on this remote machine. Okay, so I typically refer to this as the Linux server. Or sometimes people might call it the remote server, or they may just call it the server. But it's a machine that's sitting somewhere that I can't actually go and type on the keyboard, but I want to do things as if I was typing on the keyboard there. I want to open a file, edit it, compile it, run the assess command, and so on and so forth. So what I do is I run a program on my laptop called SSH. And SSH creates this connection to another program on this machine that will find out who I am, see if I'm supposed to be using this machine, and if I am, will establish a connection. So so how do I do that? So this is my laptop, right, sitting on my desk. If I say SSH username at linux.engrcs.com, it goes ahead, it talks to a program on that remote machine, they handshake, they figure out I am who I say I am, and they log me in. And now, whatever I type is being interpreted by this machine over here. Now this is just one program, right? I can open up another window here, and I'm back on my own machine, right, Nitro. But over here, I'm on the remote machine, right, which is localhost.local domain. It's a boring name. So this is one way to connect to a remote machine. Now I also have a Windows laptop, and over here I run a different program. I run a program called PuTTY. And if I say PuTTY and I type in, my username at that domain, and I hit the connect button, right, it will do the same thing. It will be running this program called PuTTY, but what that program's doing is showing me a window like this into which I can type, and what I type gets sent to this machine, and whatever this machine types gets displayed by this program. So this is the first thing to keep clear, right? PuTTY is not Unix. PuTTY is not linux.engrcs.com. PuTTY is a program that runs on your PC. SSH is a different program that runs on your PC. Terminus is another program that will run on my phone and let me make connections to this machine. So these things are called clients. SSH is a client. PuTTY is a client. linuxengrcs.com is a server. And most of what we do on the network is create what are called client-server connections. It's a client connecting to a server, and then they exchange information. So PuTTY is using a protocol called SSH. That's correct. SSH is a program that also uses that protocol. If I want to transfer files, I can run a program called SFTP, which I posted a video on the other day, and that also uses the SSH protocol. So SSH is a way to securely send information from one machine to another. Why do we want that? Because information is not secure. Inherently, anything that you send out of your machine can be viewed by anybody else, right? Particularly if you're on a wireless connection, well, the airwaves are open, they're public domain. So if my modem sends information wirelessly, that information can be read by other people. So in the older days, you would run a program called Telnet. to log into a machine. It would say username, you type in your username. It would say password, you type in your password. Those characters that you typed were freely available for anybody to read. And if the only people, using this network are the colleagues you work with, that's not a problem. But now, everything's accessible to everyone, so we encrypt our information. And so SSH is part of the encryption protocol to let us send information in a way that other people can look at it but not understand what it means. If you're taking, or when you take CSE215, we'll dig into how this works. We'll look at the actual encryption algorithms that can be used to send information securely. All right, so this is one option, right? We can make connections from our local hardware to this Linux server through PuTTY, through SSH, SFTP, or whatever. But this machine is a shared resource, right? It's a machine used by everybody. And if, for example, I want to install a program on here, I can't do it. I can because I'm an administrator. But if you wanted to install a program on here, you wouldn't be able to do it. It would tell you don't have permission for it. If you wanted to do something like change, a system command, you can't do that because you have to be an administrator. And you can't use this machine unless you have a network connection. So what's nice to have is your own version of Linux running on your own hardware. And there's a few ways you can do this. One way is to just have a machine that boots up Linux. And if you have a spare laptop, or if you're not in love with Windows and you're not, playing a lot of games or something like that, you can take pretty much any laptop and run Linux on it. And if you have a really old laptop that has, not a lot of memory and not a very fast CPU, you can put Linux on it and it'll run great. Okay, it's not a very demanding operating system.
Can you get like a Chromebook that are like $100 and just install Linux on that?
You can. So Linux on a Chromebook is a bit of a moving target. I've played with that. I've gotten it to work to some degree, but a few things. One, the disk space is usually pretty limited because most of these things have solid-state drives. And two, like I say, it's a bit of a moving target. So for a while there was a way that you could effectively root your Chromebook and put Linux on it. And then they started actually supporting it as a sort of out-of-the-box option. And that worked kind of well, but it was a little wonky. So I haven't played with that for about a year now. But yeah, there is some degree to which you can do Linux on a Chromebook.
Well, ultimately, you're just removing the software from that, right? And then just running Linux on it, basically?
Well, the ways that I was playing with it was actually running inside the Chromebook itself, so I wasn't overwriting Chrome OS. It was sort of sitting as a subsystem. If you wanted to actually blow away Chrome OS and just boot directly into Linux, that I think is a little trickier. That's probably going to take some research. Whereas on a sort of standard Windows PC, getting it to boot directly into Linux is pretty well understood at this point. People have been doing that for a few decades now. But it's also a moving target. Microsoft is kind of notorious for making it harder and harder to put other operating systems on these devices, and so secure boot, loaders, and things like that can make it increasingly challenging. Older laptops, not a problem. And like I say, if you have an old laptop, or if you were to pick up, an old laptop at Goodwill or something, even if it's, a gigabyte of memory and, a 1 point something gigahertz CPU, it'll still run Linux really well. And so that's an option. There's another option, though. If you don't have access to, hardware that you want to dedicate to a Linux machine, you can use something called VirtualBox. And VirtualBox is another program that will run inside your current operating system, but will let you pretend that you have an entirely new machine that you can put Linux on. And it's a really cool technology. Virtualization in general is pretty cool. But the basic setup would be, you know, let's say you run Windows. So here's your Windows laptop. And inside here is a program called Windows 10 or 11, depending on your risk aversion. It's the operating system that's, you know, running programs for you and so on and so forth. And so, you know, you've got a program called Chrome for doing web browsing, and you've got Steam for winding down from school and so on. And you can have another program called VirtualBox. And when you run VirtualBox, you're not replacing the Windows operating system, you're not rebooting the machine, nothing like that. You're just running a program. But this program will emulate an entire PC. CPU, hard drive, main memory, USB ports, network interface, the whole shebang. It emulates that entire PC, and on that emulated PC you can install Linux. And this is really the way to go if you're stuck with running Windows for whatever reason. Go ahead and install VirtualBox and then boot Linux onto that. And it's a really, really nice way to get the full-on Unix experience and have a machine that you can be administrator on. You can do whatever you want to it. You can, you know, blow away the whole file system if you want to see what that does and so on. And it's just a program running under Windows. And so there's some information on how to do this. If you go to the video list or the playlist through Canvas, there's a video, Intro to Using VirtualBox and Xubuntu. That will take you through all the steps for installing VirtualBox, running it, using it to install a Ubuntu system on top of VirtualBox, and then doing some customizing so you can do things like share files, share your clipboard, and so on and so forth. I think it's like a 20-minute video or something like that. But that's a good quick start guide. And if you do this, here's what you end up with. So this is the VirtualBox main window, right? And these are different systems that I've created. Right, so my Linux is just kind of a default Linux system. Here's a Kali Linux if you want to do some security stuff and so on. And if you hit the start button, it basically begins this virtual machine. And this is, you know, just an x86 based CPU. And it takes, you know, half a minute to boot up. And so there's some boot messages, and then there's a splash screen for Ubuntu is the version of Linux that I'm running in here.
Can you say one more time where that video is?
So yeah, let's go through Canvas actually. I bet it's going to make me log in. Yep. Oh no, I'm denied. There we go. All right, so go to the Canvas page, and there should be a link to lecture videos. And there's also a video timestamp index. But go to the link to the lecture videos. So Intro to Using VirtualBox and Xubuntu. So 14 minutes to unfettered happiness. And then once this is up. Is that me or is that somebody else? Oh boy. Oh, that's annoying. Like I said, I don't monetize my videos, but somebody that we won't name, but they rhyme with Google does. Anyway, all right. So So this is VirtualBox running right now, right? It's sitting inside my operating system. I happen to be running Linux underneath, but it's exactly the same experience if you're running Windows underneath. Um, and you know, I can open a terminal window, and I can look at my file system and see what files space I have, and it's all virtual. It's make believe, right? I can do pretty much anything I want on here, more or less, without affecting anything outside of VirtualBox. And I have, you know, network configurations, and I have a whole bunch of devices that I can work with, including USB devices and so on and so forth. I can search for applications, you know, and run Firefox if I want. I can install things and so on and so forth. So this is a really good approach to setting up a Linux environment for yourself if you don't have hardware that you can dedicate to Linux. And I have a Windows laptop. I run this for Linux access from there, and it's totally great. And it's fast. It's actually faster than the Windows system that it's running on top of, as far as starting programs and searching for files and things like that, which is kind of weird, but it's good. And so, you know, I can compile files, and I can do ls, and I can edit with VI, and so on and so forth. So my recommendation is go ahead and check out that video and install VirtualBox, install Linux on top of it, get yourself a Linux environment. Because you want to spend as much time at the command line in Linux as possible, right? When we get to the midterm, right, there's going to be questions about, you know, using Linux commands, making archives, moving around the directory structure, and so on and so forth. You don't have to study for those questions if you've spent the first few weeks of this course living, sleeping, and breathing in Linux, right? You'll be using these commands all the time. You'll be compiling programs, editing programs, and so on. The more time you spend here, the more second nature it's going to be. And I can shut down my system from the command line if I want. All right, any questions about any of that?
I'd asked the other day how VI was behaving weirdly in my virtual Linux box.
Yeah.
You mentioned that one file, and I found the location of the file. I just wasn't sure where is that? Because I'm not familiar enough with the file structure within Linux to say, well, where do I put that to make it do what I want it to?
All right, so let's talk about VI issues. And do I have a link to this here? I don't have a link to it here. All right, well, go to like, you know, the code from lecture or something like that. So this server ~Nick shared 224. Hop up one level, and there's a directory called exrc. If you click on that, there's a README in there. So what some students find is that when they try to use VI on a different environment, sometimes when you use your arrow keys, they don't work the way that you're used to them working. Particularly if you're in insert mode where you're typing text and you use an arrow key, sometimes the up arrow key generates a bunch of A's instead of simply moving your cursor up. If you want to restore the behavior of VI that you're used to with respect to arrow keys, go into this directory, take a look at the README, okay, and it says copy this file to your own .exrc. Okay, so what does that mean? Go ahead and look at this file and copy it, right, throw it on your clipboard somewhere, and then on the server, so let's hop onto the server. Nope, that's not what I meant to do. So in your home directory, the directory that you're in when you first log in, edit a file called .exrc. And if this was, you know, completely empty, what you want to do is come over here do a Control A to select everything, copy it, Control C, or hit the copy button, and then come in here. I'll do an A to go into insert mode, and then I'll just paste that. So I can paste with a Control Shift V, or you can right click and do a paste and so on, right? And that copies all of this into this file called .exrc. That all of this stuff will serve to restore the behavior of your arrow keys in VI. So do it in your home directory and just edit a file called .exrc and put all.
File exists on my virtual Linux machine as well.
It probably won't exist by default, but go ahead and create it if it doesn't exist.
Because that's where I was seeing it, because I was just like, oh, I'll test VI on my Linux, my virtual Linux machine.
Okay.
And the server works as expected. I think, from what I recall it from yesterday, it worked as expected.
Yeah, if you put it in .exe or .exrc in your home directory on VirtualBox, that should get your arrow keys working. And yeah, normally when you do an ls, you won't see the .exrc file. That's a hidden file, which just means by default the ls command doesn't show it to you. So let's bring this back up and play around with this.
Is that because it's like an instruction file that they don't want you to mess?
It's really just kind of a convenience. There are a lot of files in Linux like .exrc that are important, but not necessarily interesting to you on a daily basis. So when I say ls, I get a pretty clean directory listing, right? I've got a few files from 223 left over, Eclipse, some geospatial stuff I'm doing, and so on. But if I do ls-a, I get a lot more information. Most of these files I don't care about on any given day. But they're still there, they're regular files, they're useful to have.
The /A is that just basically telling it you want to see all the files?
Exactly. -A says show all of the files, including the hidden ones. So right now, if I hit the arrow keys, right, I get A's and B's and D's and C's, right, which is probably not what people want. So I'm going to go in my home directory. I'm going to edit .exrc. I'm going to paste all of that stuff if I didn't already delete it. Right, and now my arrow keys do what I want. All right, so we'll stick in VirtualBox here. It's a fun environment. So that's one way you can customize things, right? And then .exrc is a file that whenever you say VI looks for that file and decides, you know, what it should do. And some combination of all of these things combined to say, hey, if somebody hits an arrow key in insert mode, move the cursor instead of typing A's and B's and C's. If you want to do syntax highlighting, right? Syntax highlighting is turned on by default. I turned that off, so...
Is there a way to permanently turn that off? Because I have to always go in there and do syntax off.
So if you...
Because I hate it on my system, I can't ever see what happened if it ends up.
Right. So I think it's on by default on the Linux server accounts. So let me see where I put it. So I think it's just .vimrc. If you say syntax off in the beginning of that file, that'll turn off your syntax highlighting. So that's another hidden file that's useful.
So just go in and find that file and put syntax off in the beginning?
Find that file or create it. So let me change this to syntax on. Right, so now I got color highlighting on.
And the second line there doesn't matter.
Second line is just something different, yeah. You don't need that one. But, you know, VI has all of these different things that you can set. And you can hardwire those inside this vimrc file. So a lot of commands come with an RC hidden file for customizing them. So bash rc is the way that we customize a command called bash, and bash is basically what we're running when we're logged into a Unix machine. And so .bashrc is a file that we can use to customize what happens when we start our login. For example, I set my prompt to be a pair of curly brackets with a number in between. The number shows me the number of the command, right? I could change this and change, you know, PS1 to be yo. And now if I start a bash session, right, it says yo. So you can take the things that we're going to learn about customizing Unix, and you can put them inside this bash rc file and effectively make them permanent, right? So for example, QA is a shortcut for change into my directory ~/QA. And that's just something that I was doing a lot of. I wanted to go into this directory, and so if I just type the letters QA, it'll change me into that directory. Except I don't have that directory on here anymore. But so what can we do in here? We can create, for example, shortcut commands. So when I push code over to the public area, what I need to do is change my directory into that shared area, and then change the permissions on all those files so that people can read them. Well, I do that a lot, and this is a lot to type, so all I have to do is type the command open, and it will automatically switch into the shared area on the server, change the permissions on all the files. If I want to run my ODP grader to push things up to Canvas, right, I have to go into this directory and run this command. Well, I just say grader, and it goes ahead and executes all those commands. And so if I say alias, it'll show me all of the aliases that I have set up. So I have a few aliases set up here on my actual Linux system. I have a lot more. So this is on my laptop's Linux. You can also set up symbols. So I type nick@linux.ngrcs.com a lot, right? So I set up this symbol, LINUX, to be a shortcut for this big long string. And if I were to look at that using the echo command, I can say, show me what this symbol Linux means. It means nick@linux.ngrcs.com. So if I just SSH to $Linux, it acts as if I said SSH nick@linux.ngrcs.com. If I do SFTP,
Fine that that's a symbol.
say again?
The $sign just symbolizes that Linux is a symbol that you set up.
Yeah, the $sign says Linux is a symbol. Show me the value of that symbol.
Okay.
So if I say echo Linux, it says Linux. If I say echo $sign Linux, it says, oh, this is what Linux is equal to.
Okay.
So it's like a variable in C. And we'll go into the details of that in a few more days when we start talking about bash scripting. So I'm going through a lot of stuff really fast today. I'm just trying to kind of give you a flavor and talk about some general themes, and we're going to spend a lot of the course digging into the details of those and going through them more carefully. So if this feels really fast and kind of convoluted, it's okay. It means you're paying attention. But we'll come back to all of these things in more detail. All right, so some other things to keep in mind. The shell So we'll talk about shells separately, but Linux is the operating system, but there's a program running in Linux which is listening to what I type and showing me results of commands and so on. That's called a shell, and the shell we're working with is called bash, B-A-S-H. And we'll talk about bash till we're blue in the face throughout the course. But I'll use the word bash sometimes today to just mean this program. So bash has a history of commands that I've executed, and I can type the word history and see my last 2,000 commands. And this can be useful, if something weird happens, if you can't find a file you've been working on, you can go back and look at your history and maybe see, oh yeah, I moved it into another directory, right? Or something like that. And you can pull back commands from your history by just using the up arrow key. So I can go back to a previous command by going up arrow. I can come down by doing a down arrow. And you can also move around by using arrow keys, or you can use a control arrow key to move a word at a time. So maybe I wanted to log into Goblin King instead of Nick, and so I can do that. And it's just a shortcut way of not having to type, a command that made one typo in it somewhere. You don't have to type the whole command again. You can just go back and come in and edit your command. Another thing you can do is you can use the tab key to save you from having to type really long file names. So for example, I have, let me hop onto the Linux machine. Get back to my prompt. All right, so I have a few files sitting here right now. Suppose I go into my 224 directory and I look, I've got a few files sitting in here, right? Let's say I want to look at the contents of the README file. I can say cat README. It's an empty file, that's okay. But if I were to just type the letter R and then hit the tab button, it'll type the rest of the file name for me. And if I want to edit my file, I can type an R followed by a tab and say, this is a test, and then I can arrow key back to my cat command, and I can see the contents of my file. These are tiny little shortcuts, right? These will not, save you an hour. Because I can type README, it's 6 characters. I can type an R followed by a tab, it's 2 characters. But as you become as these things become ingrained in your behavior on a command line, this will end up saving you a lot of time, and it will save you focus, right? So I want to go into CSE224 work area. I can just say cd cs. I gotta go back to my top directory. I can just say cd, and I can type a C and hit a tab, and it types in the rest of that for me. And this is pretty useful, right? So, a lot of times I want to go into files, 224, fall 2021, and I want to go into, if you hit the tab twice, it will show you your options. So I can go into admin, homework, or students. So I'll go into homework, and I'll hit tab twice, and I want to look at PA1, right? I didn't have to remember that path. I didn't have to type in this big long path. And if I wasn't explaining what I was doing, this would take me about a second to get into this directory. So these are shortcuts that we'll talk about throughout the course. And I'll invite you to explore them and use them and to discover your own shortcuts. But ultimately, you come out of any course with your own sort of takeaway. And as you go through the programming courses here and at a university, you're going to be continually developing your own sort of personal toolkit, right? The things that work for you, the things that save you time, the things that stop you from having to take your focus away from your task at hand to deal with, how do I compile this program again? Where's that library that I need to link to my program to test it, right? You never want to get distracted. You never want the computer to slow you down. You never want the computer to get in your way. You want it to be there to do what you're trying to do. And so these kinds of things, using tab keys to complete file names, using arrow keys to move up, using control backspace to move through your line quickly. These are tricks that we're going to see and develop, and that will go into your toolkit down the road. So on Canvas, there's this how-to quick start guide, and it tells you how to log into the server. It looks like everybody's been able to log in so far. It talks about transferring files, so there's an SFTP command you can use to transfer files back and forth. There's also a command called WinSCP, and this is a drag and drop version of SFTP. If you're on a Windows machine and you want to move files to and from the Linux server, download WinSCP. It comes from the same place you get PuTTY, and it basically creates a pair of windows. Remote machine, local machine, you can just drag and drop files back and forth. Just make sure you get it from putty.org and not from hackme.com or something like that, because there's a lot of sites that, you know, install adware when you download programs and such. And so this how-to guide also has some initial Linux commands that can be a good sort of memory refresher. So how to edit a file, how to compile a program, how to execute a program, how to capture the output of a program, ways to look at the contents of a program, ways to see the list of files that you have, and so on and so forth, moving around subdirectories and stuff like that. Yeah, Linux is not as prone to buggy software. You generally don't have to download software from a website. There's a package manager you can use to install packages, but inevitably there's packages that that aren't part of the standard distribution, and then you're kind of back in the Wild West where you need to trust the source that you're getting the code from, and so on and so forth. But historically, Unix has not been as big of a hacking target as Windows. But you can still get viruses, you can still get adware, you can still get hacked. So you gotta take the usual precautions. So some Linux commands to get you started on here. You've got your CSE224B notes, hopefully, that went through a lot of Linux, and the textbook for the course, you know, covers way more Linux than we'll actually need in this year. But those are all good options. All right, the last thing I want to talk about today is backups. And backups are one of those things, right? There's a saying / joke. There's two kinds of people in the world: those who make backups and those who have never lost all of their work. And inevitably, things happen. Hard drives fail, machines get corrupted. You make a mistake and type a command you didn't mean to type. Files will disappear or become inaccessible. And worst feeling in the world maybe is, you know, you've worked a week on a project, it's almost done, and you're getting ready to turn it in, and you're doing one last thing, and you make a typo and you delete your source code file. And what do? There's no undelete that you can easily run on Linux. It's gone. And so, you know, you hope that you remember how you wrote it and you start trying to type it in again. So you want to make backups. And backups can be as simple as you know, I'm working on a program called stick. I can just make a copy and a file called stick2. And now if I accidentally delete stick or I make some changes I didn't mean to, I've got a backup of it, right? Or you can make a directory and just copy your files into that directory periodically. You can use a flash drive or an external hard drive to keep copies that are separate from your hard drive in case the hard drive in your PC fails. And hard drives fail eventually. But you can also go to the cloud. And we're going to talk tomorrow about something called Git. And Git is a way to make copies of your code as you work on it and be able to get back to previous copies, but it also lets you do backups offline in the cloud. And we're going to use this for this course, and you're also going to use this as a way to submit your assignments in this class. And this will be what homework 2 is, which is due on Friday. So tomorrow we'll mostly spend talking about Git, and then we'll look at homework 2. And homework 2 is kind of like a hello world for Git, so it doesn't take a lot of time once you've got the pieces lined up just right. And I think maybe there was a question. I'm going to say go ahead and send me an attendance note. Let me know that you're here, and then you're free to go. And if there was a question coming in, I'll stick around, and we can answer a question. But otherwise, send me an attendance note, and you're good to go. I'll see you tomorrow. All right. And did someone have a question, or was that just a stray mic?
It was probably a stray mic, but I do have a question.
Okay, cool.
I was not able, I was trying just now to turn syntax on, and it was saying that this command isn't supported in this version. Which seems odd.
What system are you running on?
So I'm on a Mac.
Okay.
Relatively new. So, and then I'm running in VirtualBox. I had to go back to VirtualBox, like the one back. I had to go back to like 6.1.16.
Okay.
6.1.26. As soon as I tried to set up the initial file to create the start disk, it just crashes. It would crash every time. So I looked online and said, oh, well, try going back a version. So
Okay.
it worked.
So if you're on a Mac, you basically have Linux already. Right? You should be able to open the terminal window and do VI from there and do GCC from there.
Okay.
And so you may not actually need VirtualBox. Now, if you want to get VirtualBox running, we can figure out how to do that. But to be able to...
I have VirtualBox running. I have the system that's up, it's going. It's just for whatever reason, when I tried to do when I did the vim rc, and I put in the, syntax on, and then I got an error message when I tried to, use it. So, try again.
So typing, yeah, let's see. Can you hop into office hours? I mean, can you hop into my office Zoom and we can screen share and look at it there?
Sure.
Let me close this out, and I'll hop into my office in about 60 seconds, and you can screen share from there. We can probably figure it out.
Okay.
All right, cool. I'll see you in there in a minute.
Is it okay if I join? Fine with me.
Let's see.